Good morning class and welcome. Today is the second video in this series of quadratic equations and we are going to be learning about completing the square method. In the course of this class, we are going to revise the four methods. We will learn the steps to solving quadratic equations using completing the square and learn how to use the quadratic formula. Then we are going to solve examples using both methods. So the four methods which we are going to be learning are factorization, which we learned in the last class, linked in the description, completing the square and quadratic formula, which we are learning today as mentioned, and graphical method, which will be the last video on this topic. Now let's go into completing the square. The first thing we need to know about completing the square is the fact that terms can exist which are called perfect squares, where you have p plus q all squared. That expands to give us p squared plus 2pq plus q squared. For more information on this, you can check your binomial expansion, Pascal triangle, or simply just expand this expression or factorize this, and you'll find that this statement is true. Armed with this knowledge, we can reduce our quadratic equation to a perfect square, thereby reducing or limiting the need for factorizing. So when we have the quadratic equation ax squared plus bx plus c, what we do to make it a perfect square is first of all remove a and c. So to remove a, we simply divide through by a, and to remove c, we move it to the other side of the equal to term, so that we can bring in terms that agree with us, or terms that will help make our quadratic equation into a perfect square faster. Now, if we divide through by a, we'll have x squared plus b over a being the coefficient of a plus c over a being the constant. Subtract c over a from both sides, we'll have this. And then, now, we saw that the middle term from that perfect square was 2 times p times q. Our p in this case is x, and our q in this case, which we don't know, we are going to get by removing x from here, leaving us with b over a. Remember that this is 2q, so half of this is going to be our q. So we are going to square half of this and add to both sides. Our equation then becomes x squared plus b over ax plus b over 2a all squared equal to b over 2a all squared minus c over a. Of course, we have to add it to both sides, otherwise the expression changes in value. Once we've done this, this left-hand side becomes a perfect square, and we can simplify it as x plus b over 2a all squared equal to b over 2a all squared minus c over a. After getting that, let's simplify this. By opening this bracket, we will have b squared over 4a squared minus c over a. The denominator here is 4a squared. So if we divide 4a squared by 4a squared, we get 1. 1 times b squared remains b squared. Divide 4a squared by a, we get 4a. 4a times c, we have times minus c, we have minus 4ac. Now we find the square root of both sides, since we want x to be the subject of this formula. Dividing both sides, finding the square root of both sides, we simply remove the square here and put a square root sign here. But remember that the square root of every number can either be positive or negative. Since both positive and negative numbers multiply to give the same square, such as 2 square is equal to 4, and minus 2 square is also equal to 4. Since the two negative numbers minus 2 times minus 2, the two negative signs will cancel out each other, and we have a positive square. So we cannot just exclude the possibility of the negative number, and we're going to take both of them into consideration. Of course, x cannot be the subject of the formula if we still have this expression here, so we're going to move it to the other side, giving us x is equal to minus b over 2a plus or minus square root of b squared minus 4ac all over 2a. Of course, here we had 4a squared, but the square root of 4a squared is 2a. These two have the same denominator, so we can simply add them to have a single fraction, giving us, for any quadratic equation, a x squared plus bx plus c equal to 0. The root is going to be minus b plus or minus square root of b squared minus 4ac all over 2a. As you've just noticed, we derived the quadratic formula. So this is the way the quadratic formula was developed or invented, using completing the square method. Quadratic formula and completing the square method are the two most powerful methods we are learning here, because it's not always possible to factorize expressions, and the graphical method is not always accurate. So when you have the roots of equations which are in fractions or decimal fractions, the quadratic formula and the completing the square method are two most efficient methods. Now, the quadratic formula is of course easier than the completing the square method, but the completing the square method is more versatile, because sometimes you might not need to find the answer, but you might need to solve to a particular step. So it's important that we learn both of them. Now, example, let's use both methods to solve the equation 3x squared plus 7x minus 6 equal to 0. Using completing the square, our first step will be to eliminate the a or the c. In this case, we decide to eliminate the c first by moving it to the other side of the equal to sign, having 3x squared plus 7x equal to 6, because it was negative here, because positive here. So divide through by the coefficient of x squared. So we have x squared plus 7 over 3x equal to 6 over 3. 6 divided by 3, of course, gives us 2. Then our next step will be to add half the square of half the coefficient of x. Half of this is going to be 7 over 6 multiplying it by 2. So we have 7 over 6 squared, adding it both here and here. Once we've added this, we now have our p squared plus 2pq plus q squared. So this is a perfect square, which is p plus q all squared. However, this we need to simplify. So we are going to square this term. 7 squared 49, 6 squared 36. Finding the square root of both sides, this just leaves us with x plus 7 over 6 here equal to plus or minus the root of course, when adding 2 to this fraction, the 2 will be 72. That is 36 times 2, giving us 72 plus 49 all over 36. But the square root of 36 is 6. So this square root only applies to what is in this bracket. Now 72 plus 49 will give us 121. And the square root of 1 is 11. So here we have x equal to 7 over 6 plus or minus 11 over 6. Now remember that I told you that the plus and the minus are both important. At this point, we are going to solve them separately. Solving the plus here and the minus here, we have 7 over 6 plus 11 over 6. Since minus 7 over 6 plus 11 over 6, since they both have the same denominator, we can solve this by simply adding the numerators or subtracting the numerators. So we have 11 minus 7 all over 6, giving us 4 over 6. The lowest term to that is 2 over 3. And on this other hand, we have minus 7 over 11, minus 7 over 6, minus 11 over 6. Having the same denominator, we do the same thing. We just solve the numerators. Minus 7 minus 11 gives us minus 18. Minus 18 over 6 gives us minus 3. So the roots of this equation are x equal to 2 over 3 or x equal to minus 3. Now, using the quadratic formula, we simply have to compare the equation to ax squared plus bx plus c. And when we do that, we can see that our a is going to be 3, our b is going to be 7, and our c is going to be minus 6. So once we've gotten that, those three values, we substitute them into the equation. X is equal to minus b plus or minus square root of b squared minus 4ac over 2a. And that's going to give us minus 7 plus or minus 7 square root of 7 squared minus 4 times 3 times minus 6. Of course, minus 4 times 3 times minus 6 will give us 72. 72 plus 49 will give us 121. The square root of 121 is 11. So we have x squared equal to minus 7 plus or minus 7 over 6, which is exactly what we have in the using completing the square. And so we can solve it down to get the same values. X is equal to 2 over 3 or x is equal to minus 3. I hope you're able to learn something new today. Here are some practice exercises using both completing the square method and quadratic formula. Solve the quadratic equations 2x squared minus x minus 6 equal to 0 and x squared plus 3x minus 10 equal to 0. If you have any questions, feel free to ask in the comment section below. And remember, the only way to learn math is by solving it.